For the second half of Unit 2, we're going to take some of the elements we already learned in Unit 2 and put them together. For instance, we are pretty comfortable now looking at the slope and the y-intercept of lines. So if we look at two lines and compare their slopes and y-intercepts, we're going to be able to tell how many solutions exist for a system of equations. That's just where you have more than one equation in a group. If two lines intersect one time, do you see how these two lines intersect right here? They cross once, which means they have one solution. You can kind of remember that solution is the number of times they cross. These two lines have different slopes. If two lines never cross, like these two lines, they never cross. There is no solution. And one thing you'll notice about these lines, they are parallel. They have the same slope, the same steepness. Finally, if two lines are one right on top of the other, it's not quite lined up, but you get the idea. There are infinite solutions. They have the same slope, they would be the same line, the same y-intercept, the same equation. So to compare, we want to get both of the equations in the system into y equals mx plus b form, into slope-intercept form. The first one is already done for us. But the second one, we need to add 3x to both sides so that we get y equals 3x plus 1. Because on the left, the 3x's would cancel out. I'm left with y equals 3x plus 1. Now, if I compare the slopes of these lines, they're both 3. If I compare the y-intercepts of these lines, they're both 1, which means they're the same line. There are infinite solutions. If I were to graph these two equations, they would be right on top of one another. The next set of system of equations, both equations are in the right form, so we just need to compare the slopes and the y-intercepts. The slope of the first line is -1, the slope of the second line is 2/3. They have different slopes. Right away, when they have different slopes, I know that means there is one solution. They're going to eventually cross one time. Finally, on the third system of equations, we have already in slope-intercept form, so I begin comparing. They have the same slope, so they could be parallel. But they're not the same line because they have different y-intercepts. So these would have no solution. These are parallel lines that never cross. Next, we're going to solve by graphing. Lines that just have a y variable and they don't have an x variable are going to be horizontal lines. So the first thing I want to do is mark where y equals 1. It's right here. And I'm going to put a horizontal line through that point. If a line has an x and a y, that's when we begin with b and move m. Notice there is no b, there is no number added right here. So we'll just start at 0 and we will move m. The slope is -1. In other words, -1 over 1 means go down 1, right 1. And I'm going to repeat that all the way across my graph. Then I will connect my lines, my dots rather. And you can see that the solution is right here. The solution to this system is negative 1, 1. That's the name of that ordered pair. If y equals a number is a horizontal line, x equals a number is going to be a vertical line. So I'm going to go over where x equals 2, and I'm going to draw a vertical line. That's how I graph the first equation. The second equation has a y and an x. So I'm going to look at the slope, and I'm going to look at the y-intercept. I'm going to start at 3, and I'm going to go down 1, right 2. Then I'll connect my points. You can see that these two lines cross right here, which is the ordered pair 2, 2. That's the solution to the system. This next equation, I have a y and an x, so I'm going to start with the slope and the y-intercept. I'm going to go to negative 2 and move 3, which means go up 3, right 1. Connect my points with a line. The second equation isn't quite in the right form just yet. I need to add 3x to both sides so that I get y equals 3x plus 3. I need to solve for y so that I have my slope and I have my y-intercept. So I'm going to begin at 3, and I'm going to go up 3, right 1. Well, I fall off the graph, so instead I'm going to go down 3, left 1. It means the same thing if you do the opposite. And I connect my lines. Where do they cross? They don't cross. There is no solution. Now we're going to solve with a method called substitution. To solve with substitution, just like when you have a substitute teacher, you need to take out one value and substitute another value. I prefer to do it with a chart. X plus 8y equals negative 6. Negative 2y equals x. Notice x equals negative 2y. X is the only variable all by itself on one side of the equation. So I'm going to take this and put it in for x in my original equation. I'm going to rewrite this equation, but I'm going to take out the x and I'm going to put in my new x, which is negative 2y. Notice these terms are like. Negative 2y and 8y make 6y. I can put them together because they're like. Then when I divide by 6 on both sides, y is negative 1. I'm going to take this answer and substitute it back on the other side. Negative 2 times y equals x. But what am I substituting? Negative 1. Negative 2 times negative 1 is positive 2. So now I have my ordered pair. X is 2, y is negative 1. Let's try the next one. I'm going to make a chart again. I'm going to write both equations. Now, unfortunately, none of my variables are isolated. So I can choose any of them to solve for. I'm going to choose this y value right here to get by itself. So I'm going to add 10 to both sides. I get negative y equals negative 4 because these 10s cancel. If negative y is negative 4, positive y is positive 4. So now I already have half of my answer. I'm going to take this value and substitute it into my other equation. Negative 2y minus x equals 10. Negative 2 times 4 is negative 8. Take away x equals 10. Adding x to both sides, negative 8 equals 8, negative x equals 18. So positive x is negative 18. Solving by elimination. We're going to look at two equations in standard form. Standard form means that they have the x and the y on the left side of the equation, and we have the constants on the right side of the equation. We're trying to get some of these to cancel out, either the yellow bubble, the blue bubble, or the green bubble. More specifically, the yellow bubble or the blue bubble, because they have the variables. We're trying to eliminate a variable. Now, 5 and negative x are opposite signs, but I really need this to be a negative 5x. And it's not. It's a negative x. But if I multiply this entire equation by 5, look what we end up with. We have 5x minus 4y equals 34. That hasn't changed. But the second equation becomes negative 5x plus 40y equals 120. Excuse me, not 120, 110. Now when I look at the yellow bubble, the blue bubble, and the green bubble, I can see that the yellow bubble is going to burst because the negative 5 and positive 5 cancel. When I combine my terms in the second blue bubble, I end up with 36y. And right here I end up with 144 for the green when I put 34 and 110 together. When I divide by 36 on both sides, well, I could divide both of these by 12, makes that a 3 and that's a 12. I can divide further, makes that a 4 and that's a 1, so my answer is 4. Y is 4. But I still need to figure out x. So I can take either equation, it doesn't matter which one. I'm going to start with the first equation. 5x minus 4y equals 34. I'm going to take out y and put in my new y, which is 4. 5x minus 16 equals 34. Adding 16 to both sides, 5x is 50, so x is 10. Go ahead and pause the video and try this next one and see if you get it right. Hopefully you got the same answer I did, negative 3, negative 2. The yellow bubble canceled out, 8x and negative 8x. I combined the blue bubble and the green bubble and solved for y. Then I substituted it back into the equation to solve for x. Inequalities are just like when we solve a system of equalities, except now we're going to have shading, if you recall from the Unit 2 Part 1 video. Any point in this dark shaded region is going to be a solution to this system. So there's many points I could pick. I could pick any of these points, but I could also pick points that aren't on the grid. It really doesn't matter. Any point in the shaded region. Now, when you're trying to name a point, you do want to pick a nice point. For instance, I'm going to choose this point right here. That is the point 1, 3. So that's the answer, but there are an infinite number of answers I could have listed. I could have also listed 1, 3.5, or I could list 0, 4, or 0, 5. There's so many different answers. Let's work backwards. Now we're going to write an equation for these lines. Notice I have one horizontal line and one vertical line. The green horizontal line is the line y equals 3. The purple vertical line is the line x equals -2. But these aren't equalities, these are inequalities. So I need to put the appropriate symbol. Here, I've shaded green above the green line. So I want it to be greater than. And notice this line is solid, which means I need to put a solid line under my symbol. For the purple vertical line, I've shaded left of the line, less than. And it's dashed, so I don't put a line under it. For the black line, it's a slanted line, it's an oblique line, so I know I'm going to have it in the form y equals mx plus b. B is my y-intercept, so in this case it's 5. And my slope is down 1, right 1, down 1, right 1, down 1, right 1, down 1. It's a solid line, and I've shaded above the line. So I want it to be greater than or equal to because it's solid. For my orange equation, we're going to do the same thing, y equals mx plus b. I'm going to begin with my b, which in this case is -1. I'm going to take out b and put in -1. I also need to list the slope. The slope is up 1, right 2. Which would be up 1, right 2, 1/2. Now let's talk about the symbol we need. I've shaded below the line, so it's less than, and it's dashed, so it's going to be strictly less than. Let's work in reverse. Now we're going to start with the system of inequalities. We're going to graph them on the grid. So the first equation, I'm going to begin at 8, and then I'm going to go down 1, right 1, because the slope is -1. Then I'll connect these dots with a line as carefully as I can. Precision matters. It's a solid line, and I want to shade less than the line, which would be this entire region. Next, we're going to graph the second equation on the same graph because it's a system of inequalities. And when we graph systems, that's exactly what we want to do. Put them on the same graph. All right, I'm going to use blue for this one. I'm going to begin at 5. I'm going to go up 1, right 2. Connect them with a line as accurately as possible. Notice that it's dashed because it's strictly greater than, so I need to go back to my line and make it a dashed line. I also need to shade above the line because it's greater than, which would be this area, above my line. Now I need a point that's in the solution. In other words, a point that's in the green region. I'm going to pick this point. That's the point, -6, 7. But a whole lot of answers would work in that green solution area. Let's try it again. Go ahead and pause your video and try these next two systems of inequalities rather, and see if you get the same thing I do. All right, for example 15, hopefully you got a graph that matches my picture. The point that you chose will vary, but as long as your point is in my same green region, it will be correct. Number 16 was challenging because before we could graph them, we had to get them into slope-intercept form. So I had to solve for y. Then I graphed them and noticed that the first equation was shaded lower or right, and the second equation was graphed and shaded above or to the left, the blue one. They overlap here in the middle, which is the green region. You can pick any. Apply what we've learned to the real world. If a bag contains 5 total red and blue marbles, that means the red marbles plus the blue marbles, we don't know how many there are, but we know there's 5 marbles total. We also know that the number of blue marbles is, remember how we translated from Unit 1? 5 more than 4 times the number of red marbles. Now, if we solve this with substitution, we can get the answer. I'm going to take my first equation, r plus b equals 5. I'm going to take out the b, and I'm going to substitute what b equals. B equals 5 plus 4r. If I combine like terms here, r and 4r, I'll get 5r. Plus 5 equals 5. Subtracting 5 from each side, I get 5r equals 0, which means there are no red marbles in the bag. There are 0 red marbles and 5 blue. An animal shelter spends a total of $48.50 one day caring for a total of 14 cats and dogs. So the number of cats, which we don't know, and the number of dogs combined gives me 14. That takes care of this information. But now we have a money clue as well. A total of $48.50 means how much we made on the cats, which was $2.50 per cat and $7 per dog. If I take this system of equations and solve with elimination, I'll multiply the first equation by 7. It makes that a 98. Notice I'm trying to get the d's to cancel out. I'm close, but I need them to be negative, so I'm going to also multiply by a -1. Now the d's will cancel. -7 plus 250 gives me -4.5 cats. Over here, if I take 98 and subtract 48.50, I get 49.50. -49.50 because the 98 was negative. And then finally, when I divide 49.50 by 450, I get 11. There were 11 cats. Now, if there were a total of 14 animals, that means 3 of them were dogs. 2 families go to the movie theater. The Jones family spends a total of $29.25, that's our total, on 1 drink and 3 bags of popcorn. The Baker family, wow, they spent $116.25 at the movie. They bought 9 drinks, they must have been thirsty, and 6 bags of popcorn. Now, we can solve using graphing, substitution, elimination. I think the easiest thing is to multiply this first equation by -2. When I do that, I get -2d, -6p equals 29.25 times 2, -58.50. My original equation for the second equation is right here. And if I use my color, you'll see that I'll have my yellow bubble, my blue bubble, and my green bubble. The blue bubble will cancel. I'm left with 7d equals 57.75. And if I divide both sides by 7, I know that a drink cost $8.25. Now I need to solve for the popcorn. So I'm going to take this first equation right here. I'm going to rewrite it off to the side. Drink plus 3 popcorn is $29.25. Now if the drink, we already figured that out, was $8.25, and 3 popcorns makes $29.25. I'm going to subtract $8.25 from both sides. So 3 popcorns gives me $21, which means a popcorn is $7. There are $1.45 worth of nickels and dimes. There are a total of 22 nickels. So if I take the number of nickels and the number of dimes, I'll get 22. That's the quantity equation, but we also have a value equation with dollars. So I need to take the value of a nickel times the number of nickels, and the value of a dime times the number of dimes, so that I get a value. Value times the quantity equals the value. Again, there's so many ways that you could solve this: substitution, elimination, or graphing. I'm going to multiply my first equation by -0.10. When I do that, I get -0.10n, -0.10d equals 22 times -0.1 is -2.2. My second equation I haven't changed. When I combine them, the d's will cancel out, and I'll be left with -0.5 n equals -75. Dividing by -0.05 on both sides, gives me 15. So I know I have 15 nickels Remember, altogether I had 22, so I must have 7 dimes.